My name is Gabriel Brown with Heavy Reading, and I'm here with Qualcomm to talk about 5G for industrial IoT. This has emerged as really one of the most important of the advanced 5G use cases. A lot of pull from industry, the future customers, a lot of attention from operators, and really a lot of R&D focused on this application from the vendor and technology ecosystem. So we're going to run through a demo. Pirapol, take it away.
Thank you, Gabriel. In this demo, we are showcasing the capabilities of 5G that can be applied to industrial IoT. In particularly in this demo, we are showing smart manufacturing and factory automation. We are showing a typical use of 5G that can be applied into factory. So for example, there are multiple cases where we can utilize 5G from industrial robot to handheld terminal to sensors, and all of these use cases can be supported on 5G in a single network.
Okay, so that kind of maps pretty nicely to the famous 5G triangle. I guess there's some of these applications you can support on a private LTE, right, already?
Good question. So there are some of the use cases like the handheld terminal that can already be supported by private LTE, but there are additional use cases that previously used to be very challenging to be supported by wireless technology. For example, industrial robot and motion control, those previously are being done using a cable connection. So for wireline replacement, we need to be able to meet this 6-9 reliability in a challenging environment such as the factory. And this is very difficult for wireless communication. So let me illustrate why. So in a typical factory environment, there are a lot of objects that can move around, and many of them are made of metal. So in typical wireless communication, when you have this base station that communicates to the device here, when objects such as forklift move nearby and block the signal, then the signal gets weaker, and then we have packet loss. So that's a problem for reliable communication over wireless. In 5G, we have a technique that's called coordinated multipoint, or COM, that allows these different base stations to coordinate together and then jointly transmit the signal that combine constructively at the device, which allow the device to have very strong signal at all times, even with obstruction. Now let's go to the actual test result that we have from our test bed in San Diego. So this is the result from our over-the-air test bed in San Diego, where we have 4 base stations installed in different corners of the factory and a device that are in the middle. So as you can see, when the device is being blocked by this forklift, the signal drop off very sharply, and that causes packet errors, which is a problem for reliable communication. And this is resolved with our COM. So with COM, as you can see, even when the forklift come and block the device, the signal only dip slightly, and more importantly, there are no packet errors, even in this challenging environment, because the device can still receive strong signal from other base stations that are not blocked. So in order to convince you that we can actually achieve 6-9 reliability, what we do is we need to generate many millions of packets. So we run the system over 24 hours to compare without COM and with COM. How do we improve the reliability? So first, let's take a look at the result without COM. So as you can see, in these results, because we park the forklift right in front of the device, so the reliability goes down because the forklift keep blocking the signal. Now when we turn on COM, in similar situation, eventually we'll see that for the total of 86 million packets, we only have 50 packet errors. And if you look at the reliability of the system, we always have a 99.999% reliability or 6-9 reliability that's achieved with our technology. For the system such as this, it can be operated on wide variety of frequency. Either operators can provide a system on operator license spectrum, or this system can also be operated on what we call locally licensed spectrum, where government may allocate a certain part of the spectrum that allow enterprise to deploy the system locally. So there are a lot of options here. So there are many capabilities that are already standardized in release 15. In release 16, there are further improvements to enhance the ultra-reliable low-latency communication to make the system more reliable and also more efficient in, for example, the control channel of the system, along with support for time-sensitive networking, which allow 5G system to be interoperable with legacy equipments that support industrial Ethernet.
So you're saying they're mapping the industrial Ethernet standards onto 5G NR radio interface. So you're going to get the same performance as you'll get from these specialized Ethernet connections over wireless.
That's correct.
Terrific, thank you. Very impressive. Thank you very much, Pirapol.
Thank you, Gabriel.